Today we're going to be, this unit is called sequences and series. Today we're just going to be looking at some mathematical patterns and determining how to use those. So first of all, a sequence. We're going to be dealing with sequences for a while in this unit. So sequences is an ordered list of numbers that follow a pattern. So for example, this is an example of a sequence, 2, 4, 6, 8, 10, 12. It's a list of numbers and they follow a pattern, right everybody? It's going up by 2 each time, am I correct? Okay. And then a term. So we got to get some vocabulary down. A term is, well, first of all, each number in a sequence is a specific term in the sequence. So in 2, 4, 6, 8, 10, 12, these are all different terms. And they do have a specific term. So 2 is the first term, which makes sense, isn't it, the first thing you see? So it's pretty straightforward. This is our first term. This is our second term. 6 is our third term. 8 is our fourth term. 10, fifth term, and 12, sixth term. Does anybody have any questions on what a term is? Okay, so now you're going to see it written as such. So we just talked about how every piece of a sequence is a term, a specific term. And this is how they're going to write it. So why is it not? Just a second. That thing's bugging me. There we go. No, go away. Okay. So this is our first term. This is how they'll write it. A sub 1. This is saying that this is our first term. Does everybody understand that? A sub 1. This is our second term, so they would call this A sub 2. This is our third term, so they call it A sub 3. 8's our fourth term, so A sub 4. 10's our fifth term, so A sub 5. And then dot, dot, dot. That means it's continuing, or it's endless. Like, we can keep doing this forever. So, if we have A sub 1, that's our first term. A sub 2 would be our second term. A sub 3 our third term. And A sub 4 our fourth term. Then it continues on. Now, couldn't we go to any number of terms? So, let's say I went to A sub n. That means it's the nth term. So, that means, couldn't we go to a 10th term? Couldn't we go to a 40th term? Couldn't we go to a 100th term? So do you see what I'm saying here? So nth just means nth term, like whatever term we're talking about. Now this n minus 1 just means the previous term in front of n, which makes sense. If n is 10, what's 10 minus 1? 9. Isn't that the term that comes before 10? 9, right? So this n minus 1, this a sub n minus 1 means previous term. So you'll probably want to make note of that. So the a sub n minus 1 means previous term. And then the a sub n plus 1 means the term that comes after, the next term. So, for example, if I was talking a sub 10, that would be our 10th term, then the next term would be 10 plus 1, which is 11. So it makes sense of how that's the next term, right? Everybody, does everybody understand the n plus 1, the n minus 1? N minus 1 means previous term, n plus 1 means next term, and the a sub n term means whatever term we're talking about. Questions on any of that? Okay. All right, so let's look at this equation here, and we're asked to find what are the first 8 terms of this sequence. So we're told that this is a sequence. We're asked what are the first 8 terms of this specific sequence. So a sub n means a sub n, any term, will be equal to 3 times n minus 1. Now notice, isn't this our n? Yes? Is everybody good with that? So let's go through and we want to know the first 8 terms. So I took the liberty, this wouldn't be written out for you, I just wrote this out. So we want 8 terms. So that would be a sub 1, a sub 2, a sub 3, 4, 5, 6, 7, and 8. Does everybody understand that? Okay, so let's think about it. If a sub n, this is a sub n. So this is a 1. So our n is 1, correct? So won't we just plug in 1 into our formula? Okay, so with this one we'll have 3 times 1 minus 2, right? So what's our first term in this sequence? 1. Questions on how I got that? Okay, go. Let's keep going, guys. So let's go with this one, 2. We're plugging in a 2 for n. So 6 times 2, 4. 6 times 2, 6 minus 2 is 4. So our second term is 4. Let's do 3. 3 times 3, 9 minus 2. Okay, let's plug in 4. So 3 times 4 is 12 minus 2 is 10. Okay, awesome. And then let's do 5. So 15 minus 2. Right?
Yeah.
And then 7 times 3. Okay, and then 8 times 3. 24 minus 2 is 22. So we now have a sequence built, and that would have been the formula to get each of these. Does that make sense, everybody? Okay, awesome. So now I want you to do 1 through 9. Go. Idea. Okay, so I need you to bring it back to me now. So we were just given an equation, and we were generating the sequence, right, everybody? Which we know sequence means an ordered list of numbers with a certain pattern. So we were given the equation, and then we created the sequence. So now we're actually going to go backwards, and this is a little harder, okay? So now instead we're going to be given the sequence and be asked to find the actual formula that was given to create that specific sequence. So first of all, we're going to be dealing with an explicit formula. There are 2 types of formulas. The first one we're going to deal with is an explicit formula. So in a second, we're going to be writing an explicit formula. Now you have to pay very close attention to the difference, to what an explicit formula is, okay? So make sure you're paying really close attention. So an explicit formula is a formula that gives how to get each term of a sequence using the number n, where n is the number of term you're talking about. N is the number of term you're talking about. So you can't write an explicit formula using a previous term, but you have to write the formula using n instead. So a lot of times people want to write a formula using the previous term, but with an explicit formula you can't do that. You have to use n, which means the number of term you're on. So here's the first example. Looking at the sequence 2, 4, 6, 8, 10. What you probably want to do is automatically say, don't you take the previous term and add 2, right? But that would not be okay for an explicit formula. That wouldn't be a true formula for explicit. Even though that is a true formula for this sequence, it's not an explicit formula. So if you say, okay, you take each previous term and add 2, that wouldn't be okay. We have to write an explicit formula in terms of n, where n is the number of term you're on. So remember, this is a sub 1, right? Everybody? This is a sub 2, a sub 3, a sub 4, a sub 5, and then a sub n, right, everybody? So we're going to be writing a formula in terms of n instead of previous terms. So if you look at this, this is our n value, 1. Does everybody see how it's 1? How did they get from 1 to 2? Take n and multiply by 2. Let's check to see if that works over here. If n is 2, how did we get to 4? You times it by 2. So aren't we taking n and multiplying it by 2 in each case? Yes? So that would be the appropriate formula. A sub n is equal to 2 times n. Is everybody comfortable with that? That's an explicit formula. Okay? Questions on that? Okay. So here's my first example. It says, write an explicit formula for each sequence. So first of all, we have a sequence of numbers. So we say, okay, let's try to figure out the pattern here. But since it's an explicit formula, we're talking in terms of n, not previous terms. So I always, with an explicit formula, write out, okay, so this is a sub 1, a sub 2, a sub 3, and this is a sub 4, right? So then I can make sure I'm focusing in the right spot. We're writing a formula in terms of n, which is that, right? Those are n's, right, everybody? Okay, so we're writing a formula. A sub n will be equal to, so to find the next terms, let's figure out what are we doing here. We're taking n and doing what? How do we get from 1 to 6? You're timesing by 6, but does that work for this one? Yes. 6 times n, 6 times 2 is 12. 6 times 3 is 12. So isn't it, it must be 6 times n, right, everybody? Awesome. So our formula was 6 times n. Our explicit formula was 6 times n to get this specific sequence. Now, the reason we'd want the formula is because I'm asking you now to find the 100th term. Well, you wouldn't want to have to sit and keep going clear to 100 and figure out the 100th term, right? That would take you forever. But now that you have the formula, can't you find any term using the formula? Okay, so now we want to find a sub 100. So our n is 100, so don't we just plug in 6 times 100? Yeah? Because n is 100. Are we all good? So our 100th term is 600. Questions on that? Okay, so that's why we want to be able to write a formula, because if I say find the 120th term, you don't want to have to sit and do this. It'll take you all day, okay? Let's do another one, okay? So it says write an explicit formula for this sequence. So 3, 4, 5, 6, 7. So remember, an explicit formula has to do with n. A formula with n. So once again, for explicit formulas, I always write these down so that I can focus in the right spot instead of the wrong spot. So this is what I'm looking at. I'm writing the formula in terms of n. This is my n value, because remember, it's a sub n. So we're writing a general formula here to find any term in this specific sequence. So how do we get from 1 to 3? You added 2, but let's check and see if that works here. How did we get from 2 to 4? Added 2, n plus 2, right? And then is it 3 plus 2? Yep. 4 plus 2? Yep. 5 plus 2? Yep. 7. Okay, so our formula must have been n plus 2. Questions on that? So now let's find the 45th term. We don't want to have 45 terms of going out there. So we're finding a sub 45. So our n is 45, so that must mean that's 45 plus 2, right? 47. Questions on how to write an explicit formula. You're going to look for patterns of multiplication and addition. Okay? Ready, set, go. Do these problems. Only these ones, though. So we've just been writing formulas, and they were explicit formulas, which means a formula in terms of n. Now we're going to learn about a new type of formula. There's 2 types of formulas. Now we're learning it. There's a recursive formula. So now a recursive formula is different than an explicit formula. So a recursive formula works the same way, though. It gives you a way to find the next terms of any term. So a formula that gives how to find each term in a sequence using, so once again, a formula to find each term in a sequence. And this time we're going to be using, first with the recursive formula, you do have to have an initial condition, which just means you have to specify what your first term is. Okay? So, and you'll see what I mean in a second, because we'll be given that. So we'll just specify our first term, and then this time the formula is now based on the previous term of each term. So it's not going to be based on n, but instead you're going to write a formula based on the previous term from each term. So this time, once again, the formula will be based on the previous term. So a sub n is equal to, so we are saying any term in a sequence is equal to, this is just some examples of one. So remember that a sub n minus 1. Doesn't n minus 1 just mean previous term? So this would be saying you take the previous term and add 2. The a sub n minus 1. Doesn't that just mean previous term? So it looks harder than it is. It's actually really easy. You take the previous term, add 2. Or this would be saying you take 2 and multiply it to the previous term that came before this term. Does that make sense to everybody? So that's how you specify a sub n minus 1 means previous term. Because a sub n would be the term that we're talking. Okay, so you have that down. A sub n minus 1, a recursive formula, you'd be writing the formula in terms of the previous term. So with this one, once again, you look for addition or multiplication patterns. So here we go, guys. So it says, write a recursive definition for the sequence. So here we go. We're writing a recursive definition for the sequence. So let's go looking at this. First of all, the first thing we are going to specify is what's our first term. There's way too much talking. Okay, so you'd say a sub 1, our first term is 5. Okay, so that was the first condition for writing a recursive definition. Okay, now we're going to find a sub n. Well, we're going to write a formula in terms of a previous term. So let's look. What's happening from one term to the next? Now it's okay in a recursive definition. So how did we get from 5 to 8? We added 3. How did we get from 8 to 11? Add 3. How did we get from 11 to 14? Add 3. So don't you think we're going to be adding 3 each time? So now we're going to write a formula not in terms of n, but in terms of that. In terms of the previous term. So wouldn't it be true to say you take the previous term and add 3? You take the previous term, add 3. You take this term and add 3. So you take the previous term, so we'll say that. A sub n minus 1, you take the previous term and then you add 3. And now that's our recursive definition. That's just saying the previous term plus 3, right? The n minus 1 just means simply the previous term, right? Because a sub n means the term we're on. Remember, a sub n minus 1, wouldn't that be before it? Does that make sense? Okay. So now that's what we're going to do. We wrote a recursive definition. We have our initial starting point. So this one would actually be really, we're writing a recursive definition. You don't use this to find any term in a sequence, if you think about it, because if we wanted to find the 20th term, we don't know what the previous term was, right? By just looking at this, we have no idea what the previous term is. So it's just having us write a recursive definition, and we wouldn't probably use it to find the next terms. Okay. Yes? Okay. So let's look at this one, writing a recursive definition for the sequence. So once again, a recursive definition means you're writing a formula to say how you got from one term to the next. So we can consider the previous terms. So our initial starting point of this specific sequence is 1. Now we can write our formula. So a sub n is equal to. So let's figure out, how are we getting from one term to the next? How do we get from 1 to 2? There's 2 ways. You either added 1 or multiplied by 2, right? But let's look. How do you get from 2 to 4? Multiply by 2. So you're saying we're multiplying by 2. To get from 2 to 4, we multiply by 2. To get from 4 to 8, we multiply by 2. 8 to 16, we multiply by 2. So aren't we taking the previous term and multiplying it by 2 to get that term? So to get the term, then we take the previous term, multiply by 2. So we would say 2 times a sub n minus 1. Isn't that just saying 2 times the previous term? Okay, and that's how we get the term we want. Questions? Okay. So let's do this one. So it says write a recursive definition. So this one's a little bit trickier. Now let me give you some advice here, guys. If you need to know if it's addition or multiplication, you always start off by testing a few things. So first of all, let's look. Now I'm going to try division I'm going to try multiplication first. So I'm going to take 1.5 and I'm going to divide it by 3. That's 0.5. So that means we multiply by 0.5 to get from 3 to here. Does everybody understand that? You take this and divide it by this, then that means that's the value that you took this and multiplied by. Okay, let's try this one, 0.75. So 0.75 divided by 1.5 is 0.5.
Yep.
So are we multiplying by 0.5 every time?
Yeah.
Okay, so to get from here to here, I multiply by 0.5. I multiply by 0.5 to get from here to here. Now check, make sure, so 0.375 divided by 0.75 is 0.5, so that means we took 0.75 times 0.5, you could even check it, so we're timesing by 0.5. Okay, awesome. Now, with definitions, because isn't timesing by 5 timesing by 1/2? Everybody, isn't 0.5 1/2?
Yeah.
Isn't multiplying by 1/2 saying we're taking these and dividing them by 2? Well, with the definition, a recursive definition, we always write it as a multiplication. That's why we would say multiply by 1/2. So if you're saying, oh, I can see we're dividing by 3 each time, wouldn't you just say we're multiplying by 1/3? Isn't that the same thing, guys?
Yeah.
Okay. So we're going to write our definition. So we have our initial condition. Our first term is 3. Our a sub n is equal to, you take the previous term, you took 3, and you multiplied it by 0.5. So you take the previous term, which is written as a sub n minus 1. You take the previous term and you multiply it by 0.5. So I'm going to write multiplied by 1/2. And I'm going to put it in front because that's the pretty way of putting it. Is everybody comfortable with that? Okay. These are what you're doing, and that's all that's due. Okay, so I'm just going to do, to finish this up, a couple examples off of the back, and then I'll tell you which ones are required of you to do. Okay, so you'll want to pay attention because it's less work for you if you do, and then you'll know what you're doing. Okay, so it says, is this explicit? So read the directions. We're on the back sheet. It says, determine whether each formula is explicit or recursive, then find the first 5 terms of each sequence. So I'm going to do number 38 with you. So looking at the formula, is it explicit or recursive?
Explicit.
It's explicit, right? Because it's in terms of n. The formula is written in terms of n, so we would say explicit. So then remember, explicit formulas, we can go through now and find the first 5 terms. So this would be a sub 1, a sub 2, and so on. So we're plugging in a 1, right, for n? So that would be 1/3. Is everybody good with that? And we'd be plugging in a 2. So 1/3 times 2 is 2/3, right?
Yep.
We'd be plugging in a 3. 1/3 times 3 is 1. We'd be plugging in a 4, which is 4/3. We'd be plugging in a 5, which is 5/3. So those are the first 5 terms to this sequence. So next one. This one you guys need to pay attention to. Okay, for sure. So number 42, we're given a sub 1 is equal to 5 and a sub n will be equal to 3 minus a sub n minus 1. Isn't this in terms of the previous term? This is a sequence based on the previous term, a formula based on the previous term, which is recursive, right? Okay, so now watch. This is where some people get really thrown off. So make sure you're paying attention so that you really know. So first of all, remind yourself, what is a sub n minus 1? Doesn't it mean the previous term in the sequence? Okay, so let's look. We have to know where we're starting with these. Where are we starting? 5. So our first term is 5, right, everybody? Yeah. So now let's find this next term. You take 3, subtract the previous term. So it would be 3 minus 5, which is? Good. So now we take the next term, we take the 3 minus the previous term. So won't that be 3 minus? -2? Yeah, it's -2. Right? Because it's 3 minus 5, which is -2. That's okay. So then we take the next one. Here we go. So we're plugging in a -2. So it's 3 minus the previous term. The previous term to what we're trying to find is -2. Does everybody understand what I'm saying? So 3 minus -2. Won't it be 5? Yeah. Okay. So now we're on this term. You take 3 minus the previous term. So what's it going to be? 3 minus 5. -2. So aren't we bouncing back and forth in this one? So 1, 2, 3, 4. So what do you think we're going to be at? 5. Good. Questions? What's your question?
Why do you keep going back and forth?
It just came out that way. We calculated them and it came out that way. Well, you do, to find this term, you take 3 minus the previous term. Wasn't the previous term 5? Right? That means previous term?
I got it.
Okay. Any other good questions? Okay. So this is what's required. The rest is not required. You can cross out the rest if you feel so inclined. 38 through 43.